It's been a while since we ran our season on artificial intelligence. And if I were to pat myself on the back, I would say it was serendipitous that I planned it at the same time large language models were starting to change the NLP landscape. If I missed the ball on something, it was probably running a season on computer vision right now. We've seen a mirroring set of advancements, most notably the recent diffusion models, and it's astounding to think how far we might go with this more or less identical underlying architecture used for both language and vision. If there's one thing I'm confident about, it's that the true test of whether or not something is artificially intelligent can only be performed with Alan Turing's imitation game, or as some of you know it, the Turing test. And despite recent advancements, it seems pretty confident we're still a ways off from an AGI. But between now and then, we're going to need bigger and badder challenges to press our machine learning algorithms up against. I mean, people still publish on MNIST and ImageNet a bit, but if there's one lesson we've learned, it's more data and more distributed are the two paths to push forward on. So that's why I wanted to take a quick respite from our ad tech season and bring you a story about a collaborative benchmark known as Big Bench, or the Beyond the Imitation Game benchmark. This is a large collection of many different independent tasks in natural language. And it was a major feature of Elmo and BERT and all the other models that have followed since that they're useful in a wide assortment of seemingly independent tasks, or that the BERT embeddings used as features in an MM model will allow you to train something with hundreds of examples where you previously needed maybe hundreds of thousands. Big Bench is one of the best benchmarks out there as we try and build algorithms that can be as general purpose as possible. So today I speak with returning guest Mor Geva. We talk about StrategyQA, her specific contribution to the overall project, as well as touching on what Big Bench is in general. All that and more coming right up.
Okay, so hi, I'm Mor Geva. I'm a researcher at the Allen Institute for AI. I'm working in the field of natural language processing and specifically interested in interpretability and robustness of language models.
Yeah, and welcome back to the show. I've been very pleased to see a number of interesting things pop up on your Google Scholar since we last talked, so I'm glad to be chatting again.
Thanks, Kat. It's great to be here again, of course.
Maybe we could pick up in a similar spot. Originally, we talked about annotator bias, and I'll have a link in the show notes to listeners who want to go back and hear that episode. But I know you've got at least one more publication out since looking into not just the annotator bias, but maybe a source of where some of it comes from. What can you tell me about that?
Yeah, so we had a follow-up work with great collaborators from Arizona. This was about, so in the original paper, we found out that in natural language understanding datasets, like you said, there's annotation bias created by the annotators, the people who label the data or write questions, for example. And in this follow-up work, we actually identified a bias that originates in an early stage in the process, in the dataset creation process, in the instructions given to the annotators. We just looked at a bunch of data sets, actually a big number, I don't remember the exact number, maybe a dozen recent question answering data sets, and analyzed the annotation instructions given to the annotators. And we just observed that there are clear patterns in the examples in the instructions. So the tasks, right, the annotation tasks, they are given to the annotators and they include just a few examples, and the examples are really similar. Consider, for example, a dataset for temporal reasoning, right, questions that require reasoning about time. And so the instructions include about 5 examples, and all of them start with the same wording, right? Like, when did this person did something? Yeah, so we observe this kind of bias, and then that the annotators just, propagate this bias into the data set. So it's not like the entire fault is not of the annotator. It's already starts with the people who create the data sets.
Yeah, I mean, if this were just an algorithm and there was this hidden feature that all of the answers you're looking for start with the word when, I know it's very easy for machine learning to check. Does it start with when, yes or no, and decide based on that? But it's somewhat surprising that a human annotator would find this almost like cheat kind of approach to it. Are these good faith annotators? Could that be the issue, or are the instructions really confusing for them?
Yeah, so I don't think the instructions are confusing. I just think that many crowd workers, so typically, people collect data sets with crowdsourcing. As it's in crowdsourcing, the crowd workers just want to make a lot of money in a short time. Sometimes they don't really think a lot about the instructions and what the task creators want to achieve. They just quickly look at the examples and do the most similar thing they can come up with. And so if the instructions include all kinds of biases, this will just naturally propagate to the behavior of the annotator.
Yeah, makes sense. A crowd-funded worker, I mean, they can contribute for sure, but I think we almost have to manage them in a certain way. Like if I found out there was a hedge fund that did investments based on surveying crowd workers, do you think this stock will go up or down? I wouldn't invest in that hedge fund. It doesn't sound like that's a good source of wisdom. But for, tense disambiguation or some of these NLP tasks, surely there's enough quality in the workers to get something out of it. Or am I too optimistic?
No. So I think you got this correctly. It all depends on the nature of the task, right? So there are tasks that require more creativity, more diversity, like thinking more about what you are doing. These tasks, one could argue they're simply not suitable for crowdsourcing. You need experts. There's a thin line that goes between these tasks, right there, and so I don't know, sense disambiguation or tense disambiguation. I think these are things that require less creativity. But when it comes to writing challenging, for example, right, when it comes to writing questions that we are going to discuss in the rest of the episode, like in strategy QA, then it's really hard. I mean, not only for crowd workers, for humans in general, coming up with creative, diverse questions, it's just hard.
Well, when we spoke last, you had some advice for how to get the right annotation and check your annotators. It seems like maybe there's some wisdom here to be had about a researcher creating the right interview questions and these sorts of things. Are there any ways you can summarize some of the findings that a listener might take into their own work?
Oh, right. Yeah, so I guess I don't have a good advice on how to phrase the instructions, except that you need to be very concise and concrete about what you need. If you could phrase your task in a very simple manner, like explaining to a 5-year-old or something. That's what I'm thinking when I'm trying to write instructions for crowdsourcing. And you also need to provide a lot of examples for the crowd worker. But there is advice that goes beyond the instructions, right? So this is how you construct the entire crowdsourcing pipeline. For example, what we did in a follow-up work in StrategyQA, usually what people do, this is also finding from the earlier work about annotator bias, usually people just find a very good annotators and let them write most of the examples in the dataset. They're happy with these crowd workers and they just let them create the examples. But what you can do is just to, recruit new workers as you go, just to limit the amount of examples written by a single annotator. This really improves the data quality and diversity. Yeah, so I think this is one big advice that I took from this work.
It takes a lot to put some of these data sets together and then to open them up.
Yeah.
Can you talk about that process with Strategy QA?
Wow, this was a long process. Strategy QA took us a year and a half to construct this data set. Yeah, so our major effort was about really to create a diverse data set that includes creative questions, to inspire creativity. This is needed generally in many natural language understanding tasks, not just what we tried to do in Strategy QA. So maybe it will be interesting for many people. One thing we did there is to like shift the classic crowdsourcing pipeline. So typically when you collect question answering datasets, crowd workers are presented with, some context, and they're being asked to write questions about it. The answer is in the context. They write questions that they know what the answer for the question is, right? So because it appears in the context. And so this really limits creativity. Not all data sets were created this way, but it's like a very common scenario. What we did with StrategyQA is just to remove the context. We just said, okay, let's just give the workers a chance to write a question without any context, right? So they won't get biased, or their creativity won't be limited to like a single paragraph they see in front of their eyes. But we had to give them something, right? We had to prime their creativity somehow. If I would just ask you to write many questions out of the blue, it's kind of difficult. So what we did, we just primed them with common terms that they can understand and they have some knowledge about. So we just sampled terms from Wikipedia. For example, common terms like, dog, George Bush, whatever, you name it. And, every worker has its own background and knowledge and so forth. But it inspires creativity because we just ask him, okay, so write a question about dogs. Once you get the question, it's not biased to some context.
Yeah, I'm curious then about, I guess, the diversity of questions you get. Like if you ask me, write a question about dogs, mine will probably be scientific. But maybe my sister-in-law, who has a dog and loves dogs, hers would be about breeds, because she knows about breeds and I don't. So it seems like it could be a nice step for getting a wide breadth of questions. What did you actually see when you looked at the results?
So we did get a lot of different questions, but still, we had to explain what we want. So in StrategyQA, we actually wanted a very specific type of questions, right? It's not just that we wanted any question. We wanted questions that require implicit reasoning. If you look at most available question answering datasets, it's easier to explain what implicit reasoning is after you understand what explicit reasoning is. So if you look at most datasets for question answering, like complex question answering, right? So these are questions that require reasoning over multiple pieces of text, right? For example, was Aristotle alive when the laptop was invented? These kinds of questions, once you see them, you just know from the language of the question how to answer it. Like, what are the required reasoning steps to answer the question? So in the examples that I just gave, like, was Aristotle alive when the laptop was invented? Even if you don't know who Aristotle was or anything about laptops, you could still break this question into reasoning steps. You would check when Aristotle lived and when the laptop was invented and compare the dates, right? Mm-hmm. So this is explicit reasoning. Now, what if I would ask you, did Aristotle use a laptop? This question, it doesn't give you any clues about how you should answer it. It doesn't give you the strategy for answering it. You should infer that given your, based on your, knowledge and background and so forth. Common sense reasoning. So it's the same reasoning process is needed for both of these questions. It's just that the first version, was Aristotle alive when the laptop was invented? It's like the steps are given to you. While in the implicit version, did Aristotle use a laptop? You have to infer these steps by yourself. So I hope that was clear.
Yeah. When you say, was he still alive, there's a hint there, kind of a surprising and subtle hint that time is the tool to use to answer it. And then that's gone, I guess, in the implicit version.
Exactly.
So I get the goal in that example, but I don't know how to get that algebraically. How can we look at a sentence and decide is it explicit or implicit?
Okay, so once you're given a question, it's just about trying to come up with the process, with the steps for answering it, and then see if there's an overlap between the process that you came up with and the language of the question. I mean, it's easy if you look at example. Like if you look at commonly used data sets for question answering, like, I don't know, Hotpot QA, it's just like obvious. I don't know, you see the question, and if you break it down to steps, then it's clear, right? So you don't need to know anything about the entities in the questions. You can identify core components in the questions. These are typically entities and relations, right? So in the previous example about Aristo, so the entities are Aristo and the laptop. The relations are, I don't know, the year of death or year of birth and the year of invention. So if you can identify these components in the language of the question, like in the explicit version, then the question is explicit, and it's not otherwise, right?
Can you talk a little bit about the size of the StrategyQA dataset? How many questions are in there?
We collected almost 3,000 questions, so it's not a huge data set, but it's good enough for benchmarking. Yeah, so it's about 3,000 questions, and we split them into training and test set. And the test set is hidden, right? So we have a leaderboard. Yeah, so we did a lot of analysis to see that the data is diverse as we wanted. So it's about 50-50. So it's yes-no questions, right? So it's a Boolean question answering data set. Mm-hmm. So it's about 50-50 ratio, which is great. I mean, during the data collection process, we observed that it's easier to write questions with the answer no. I don't know why, but it's just like easier. So we actually had to encourage them to write also questions with the yes answer. But yeah, so it's 50-50. Like I said, we recruited new workers along the way. So we provide all these numbers in the paper, right? So if anyone is interested, they can check the paper out. But there were a few dozens of annotators. So it's a good ratio, right? Because there are 3,000 questions and a few dozens annotators, so it's quite good. We also have like nice diagrams that show the distribution of the topics, right? So because, like I said, we primed the workers with common terms, and these terms were sampled from Wikipedia. And so in Wikipedia, you have this nice property that you can map like each term or, page title to a higher level topic. For example, dog can be an animal or something like that. Or president can be occupation. Sorry.
Yeah.
So we just mapped the terms. Yeah, we have a nice diagram that shows that the dataset is very diverse in terms of the term, like the topics it covers. And finally, also in terms of reasoning types. This is like the really important property because we wanted a dataset that covers a diverse set of reasoning types. Like not all the questions require temporal reasoning. We wanted like a diverse set of reasoning strategies, like, physical reasoning, using all kinds of knowledge. There's also like arithmetic reasoning. So we also analyzed that, and we observed that the distribution of reasoning skills it's pretty not flat, but balanced, right? So it's not skewed. There's not just a single reasoning type.
Is there like a formal taxonomy of different reasoning types?
No, I wish. It was super hard. It was super hard to do this analysis. Even if you take the same question and ask 3 different people, we actually did that. We just sampled, 100, 200 questions, I don't remember. And for every question, we just asked 3 different people, like, to annotate the reasoning types required to answer this question. And there were a lot of like disagreements, because there is no ontology. So it was super hard. But yeah, I guess it is what it is. It's like it comes up to, trying to organize the entire world in some ontology. It's impossible. I don't know. So.
Are there any historical precedents, like do language models struggle more with spatial reasoning than temporal reasoning or anything along those lines?
So that's a great question that many people asked us, even the people who reviewed this paper for TACL, like transactions of ACL, they asked us, and we just don't have a good answer. We tried to break down model performance by different reasoning types. And it's really hard to identify very specific reasoning types in strategy QA that are more challenging than others. But I mean, we had a follow-up work. I'm not sure if you want to actually cover that, but
Sure.
we had a follow-up work where we tried to decouple these two steps of coming up with the right reasoning process and actually executing it. Let's go back to the Aristo example. Okay, we assume that models that succeed on this benchmark have to do two steps. First, they have to come up with this reasoning process. Like, okay, to answer this question, I need to check when Aristo was live and when the first laptop was invented. And the second step is actually executing this reasoning process to figure out the answer to the first step, like when Aristo lived, to figure out the answer to the second step, when the laptop was invented, and then actually do this comparison of the dates and come up with the final answer. Now, we try to evaluate the ability of models on the first step. Like, how well can they just come up with the right strategy? And we actually got pretty surprising results. We analyzed GPT models, a few GPT models, also including the big one, the 178 billion params, I think.
Mm-hmm.
Maybe, yeah. And
the one you need special access to, right?
yeah. And it does pretty well. Like, we were pretty shocked by this, right? Even for, we just prompted with a few strategy questions, and we evaluated if it can come up with the right reasoning steps. Or to be more specific, like the entity relation pairs. It does pretty well. Even if you, for example, do not provide it with any similar question or question that requires the same reasoning process, we can ask the model about the Aristo example, but without providing any temporal reasoning question in the prompt, it still can do that. So we were pretty shocked by this. And this might also suggest that the reason for failing at StrategyQA is not because these models they don't know how to answer these questions. They know how to answer these questions. They just fail to do that.
Yeah, could we talk a little bit about the leaderboard? What do some of the, who's on it? How well are they scoring, and those sorts of details?
Questions from StrategyQA, they appear in two benchmarks, like two leaderboards. There is the official leaderboard in AI2's leaderboard, where we have the full setup, right? That includes the questions and also the other more rich evaluation, if you want. And there's also the evaluation as part of Big Bench. And these two are kind of different evaluation settings. So for the leaderboard in AI2, with the full setting, question answering setting, I think it's still there was some relatively small improvement compared to baselines that we reported in the paper. I think the best model reaches about almost 70, maybe 69 point accuracy. And the original performance we reported in the paper is about 65 maybe. I mean, it is an improvement, but it's not a dramatic improvement.
Right.
And I think the best model that obtains that is a model that decomposes the question somehow. It tries to answer it in steps, right? So to do some retrieval, generate an intermediate answer, and then another step of retrieval and so forth until it generates the final answer.
Interesting. So I would say, at least what you described there, that model has some architectural or structural advantages. What I see in a lot of other cases is the model with the biggest training set seems to win. Do you have a sense of how that's playing out here? Does your architecture have a major impact?
Yeah, so I must say that this model, I'm not one of the creators of this model. It's just that, it's just on the leaderboard. I'm actually not entirely sure who are the creators of this model, but should check. I'm not sure if it's even anonymized or not. I think that it's not a problem, but the challenge, right, is that, for StrategyQA, you actually have to do multiple steps to come up with the answer. It's a pretty complex process because, it includes also to come up with the reasoning process and also make have the information encoded somehow in the model and then to reason about it. So it's a lot of steps. I think the big models, like, they struggle with it. This is one of the unsolved challenges for these big models. I can say that, there's this recent line of research of chain of thought where you prompt the model while giving it iteratively, like, the steps, right? You just feed the model each time with another step in the reasoning process. Subworks from Google, they actually tried that on examples from StrategyQA, and I think they saw it gives some improvement, but there were just, I should double check that, but this might be the case, right? These are just really complex inputs, like, in terms that they just require multiple processing steps, and this is just something that might be hard for these models. And so, like, using these structured models, the ones on the leaderboard, it just gives some advantage in this case.
So strategy QA is all yes or no questions, and I believe you said they're balanced. So to put that 70% accuracy that the leaderboard is getting to now into sort of a frame of reference, would 50-50 be, or 50% be my accuracy if I was random guessing?
Yeah, so I think it's not exactly 50, maybe I think it's about 46 or 47%. So it's not exactly 50, but yeah, 70% is better than random.
But not, at the sort of level I guess I would expect a human to perform. Or do you have any insight there? How would a typical person score?
Yeah. So this was evaluated also by us, like in the original paper, but also as part of the Big Bench benchmark. So what we found basically is that, okay, so these questions are even challenging for people, right? For humans. If I would give you a bunch of strategy questions, you are likely to fail on some part of them. But if I would let you answer these questions while having access to some web search engine, then you would do well, like very well. And we report this number in the paper, I think. Let me check that actually. Let me open the paper. Okay, so for your question about the portion of yes questions, like yes no answers ratio, so it's 46.8. So this is the answer to this question. And for human performance, so 87% accuracy when given the access to web search engine.
And how do we square that against the performance we'd ask of the language model, which I guess perhaps you could make a language model that could use the internet, but I'm not aware of that going on. Is it truly a apples to apples comparison?
Well, these language models are trained on the internet, basically. So maybe. No, for sure. It's not really, it's not really apples to apples. But I don't know. I think it's kind of an indication, right? Because, it's pretty known that, these large language models, they memorize all these kinds of factual statements, right? So they know, if you would just probe them with when Aristotle lived, they will generate the right answer. And they also know when the laptop was invented. So I think you can safely assume that, at least when it comes to common entities, like not those from the tail of the distribution, the model knows a lot of things about these entities. So I think it's fair to assume.
Well, you'd mentioned strategy QA being really a benchmark data set. Could you comment a little bit on where benchmarks are at and their importance in natural language processing in general?
Wow, that's a good and hard question. Yeah, I think in a sense, benchmarks shape or drive progress in natural language understanding, and also, it's kind of like the same thing, right? We just use these language models for everything. There's this trend, right, that you can't it's very hard to evaluate what model knows with just a single data set. This era was was long ago, because these models became so good at so many things and so many tasks that you actually need to find where they succeed and where they fail. This is why we have benchmarks like Big Bench, right? It's not like the single benchmarks that have, all like a big collection of different tasks. There are other efforts like this in, I don't know, the last 2 years or so, because it's really hard. It's really hard, both because these models knows a lot of things and are very capable, and also because there are a lot of evaluation challenges, right? It's hard to create good benchmarks without biases, and you never can know. I mean, it's hard to know when the model really provides the correct answer, or because it knows the answer, or for the right reasons if you want, or if it generates the answer because of some, I don't know, shortcut or bias or I don't know what. So
yeah.
these benchmarks, they really help to figure out what these models are capable of and what they fail at, which, drives progress and yeah, interesting insights.
Well, we mentioned Big Bench a couple of times, but I don't know if we formally defined it yet. What is Big Bench?
Right. So Big Bench is a large collaborative effort initiated by Google maybe 1.5 or 2 years ago, something like that. It's a benchmark that aims to measuring the capabilities of large language models. What are the challenges for these models that we still, do not succeed at? Also, what capabilities emerge with scale, right? So this is like an interesting question that this benchmark addresses. So this benchmark includes about 200 tasks, I think, that were created by the research community. They are pretty diverse. They cover a lot of, from arithmetic tasks to question answering to social biases, like very diverse benchmark.
Yeah, it seems like they've tried to cast the net very broadly and get a lot of diversity in the types of data sets. But then again, you have to be picky to get a good collection. What about StrategyQA made it stand out to be included in the Big Bench?
I think the criteria by which we evaluated tasks, I mean, I don't remember the entire criteria, but you needed tasks that are challenging for models. Otherwise, it's not really interesting. And you also need tasks that cannot be solved just by memorizing the internet, right? Because we know these models are trained over really huge amounts of text and that they also memorize data instances. And so you just don't want these kind of tasks that can be solved this way. And yeah, I think these were the key requirements. I mean, there were also like, computational requirements in terms of execution. Yeah, I think StrategyQA just fulfilled these two. It cannot be solved just by memorization because you need to what we discussed like a few minutes ago. We just observed that it's really hard for language models.
So, who is the Big Bench data set for? I can't imagine it's just one person sitting in their apartment trying to create AGI. There are probably a few steps to get onboarded. Who is the audience or the user?
It's a bit sad to say, but I think that right now the main user of this benchmark is just the big tech companies that can build these large language models. I mean, of course, you can evaluate also models that are trained with an, academia budget, but the real interesting part comes when you just take these huge models that succeed on many different tasks and just evaluate them. So right now, I think the main user is Google, Amazon, I don't know, Microsoft.
So using all these data sets can be a nice benchmark. I don't know if there's like a formal contest going on yet for who has the, highest scoring model or whatnot, but what are some of the goals in that regard? Will we, from this, emerge some impressive new acronym that we all say is the bleeding edge?
The actual paper just came out, I don't know, 2 months ago, 1 month ago. Mm-hmm. So it's kind of new to the community. So it doesn't cover tons of models. It covers mostly like models from Google and OpenAI, like GPT, and also the recent models, Palm, and there was another one that I forgot its name. Yeah, there were like several insights from that. Like what types of skills emerge with scale? This is one question that they tried to evaluate. And they also had like an interesting insights in terms of the modeling itself. So I think they found out that models that have some sparsity in there, I'm not sure exactly where, but sparse version of GPT has some better performance on some tasks compared to the non-sparse version. So it's a bit early to see, where this goes to, because, it basically just gave a snapshot of, okay, these are the kinds of tasks that models fail to answer. These are the tasks that they successfully answer. And once you scale the model and consider really large model, there were some tasks like that. I don't remember exactly which tasks, but there were tasks that, GPT fails to answer, but when you go up to Palm, you get really better accuracy or performance.
Interesting. Certainly some behaviors do emerge. We know that's for sure. The interesting behavior we're all wondering if it will emerge is artificial general intelligence. If we put a pause on the type of research you do, and we just focused on more parameters, faster GPUs, more distributed, bigger data sets, just sort of the raw, low-level efforts, is that enough to one day get us to AGI?
Well, that's a heavy one.
Of
But
course.
no, I don't know. Personally, I think no, because like one disturbing phenomenon that was observed in multiple works, also in Big Bench, is that as you scale up the number of parameters and so the data the model is trained on, the models become more racist, like they have more social biases in them. I don't know. I think it's just the model just reflects what it was trained on, right? So the data it was trained on. And I'm not sure, like, this just lots and lots of text. It does not encode like general artificial intelligence. Like it does not encode a lot of small nuances that we humans have. I don't know. It's just hard for me to believe that even if you train on tons and tons of text, you would just get. So it's kind of personal, but I just have my second child born, and you just see that how it grounds everything in the world. You can't really achieve full intelligence from text. I don't know. You need to ground this somehow in reality. Yeah, I don't know. But I don't have like good arguments why you can get intelligence just from text. It just doesn't make sense to me.
Yeah, I share your sentiment there too. I don't know, maybe Big Bench 2 needs to have images and video in it as well to somehow make it all work. Who knows?
Yeah. So people start to work on, on these areas, like training these models both on text and images and sound, also like speech. Yeah, this is really interesting research direction. I don't know. It will be super interesting to see what comes out from this.
So there's been some contrast between Big Bench and Alan Turing's imitation game, which is sort of, I guess, the gold standard for determining if a machine bears the property of having artificial general intelligence. The imitation game, to me, is a more general system than all of the data sets covered in Big Bench, because I could ask a question from any of those data sets, or I could make up my own. And there's a certain robustness to that interactivity. I guess what I'm wondering with that in mind is, are these benchmarks really going to be the driving force the whole way? Will we just keep adding new styles and eventually that'll push NLP? Or does there need to be yet another revolution of some kind?
Well,
all big picture stuff, of course.
Yeah. I think essentially the fundamental problem that we have to somehow, I don't know, overcome is that right now in NLP, we train these huge models, right? We train them and they are really great, but they're essentially just snapshots. There's a snapshot of the data. Like we train them, we know they have problems. For example, the social biases, but then we try to fix them. These models, if you ask them, who is the president of the United States? They will give you like a specific answer to the time they were trained.
Yeah.
They don't get evolved with time. They don't get updated. They're not interactive in a sense, right? You just train them once and then that's it. That's what you have. And the world is changing, and every person that interacts with these models is different, right? It has a different background. For example, there are a lot of opinion questions, right? So if you would ask different people in the world, they will give you different answers. So I think this is like one of the missing elements in these models. They're just not general enough. They're I don't know. I think this also, being expressed in the way we evaluate these models. Big Bench is great, but you can always come up with another task that the model will fail on. I don't know.
Yeah.
Just take the question from StrategyQA and write it in a different language, for example. Take an example and change the time of the questions such that it's after. I don't know. You can take, for example, GPT-2. It was before COVID, right? So it knows nothing about COVID. I don't know. So I think this is one big challenge that we have to come over.
For sure. It's definitely going to be interesting to see how the updating or retraining process becomes more commonplace.
Yeah.
Mor, is there anywhere people can follow you online?
I have a Twitter account, and I'm always happy to talk with people about research and NLP. I have my email address on my personal webpage, so feel free to reach out.
Well, very good. We'll have links in the show notes. Thanks again for taking the time to come on and share your work.
Thank you for having me. It was great talking to you, Kyle.
Well, that's it for today's episode of Data Skeptic. Here's what I've got coming up for you next time.
Over 95% of people used Google at least once, and among these people, Google accounted for over 90% of their browsing. So if they went for other search engines, it was for 10% or less of their total browsing.
That's next time on Data Skeptic.